Okay, so now in today's lecture we will discuss about the unit outcomes which are expected from your side after completion of the curriculum of this second unit. That is, you should be able to describe this with the sketch the function of given part of the PLC. So a PLC stand for Programmable Logic Controller. Now PLC has different parts. It has the input module, it has output module, it has processor units, it has power supply. So there are different parts of the PLC. So you should be able to draw the sketch that input module looks like this one, output module looks like this one, what is inside the input module, what is inside the output module, the circuitry of that one. So that we are going to discuss in the unit number 2. Then you should be able to describe the function of specific part of the given discrete IO module. So there are two types of input output. IO stand for input and output. Okay, so my PLC has two types of input output. Discrete means digital input module, and second one is the analog input module. Okay, so in the second part you should be able to describe the function of specific part of the discrete input module. Okay, now in third part you should be able to identify the function of the given analog input and output module. So as we already discussed, certain parameters are analog in nature. That's just as in case of the process industry. When I'm going to discuss about the process industry, it has the temperature, pressure, then velocity may be there. These are the analog inputs. Now what is going to be happen with the analog inputs? The analog input does not suddenly get changed. They will change over the period of time. Okay, they will require to some time to go from zero position, means off position, to the on position. So that time period is called as the analog. Those inputs are called as the analog inputs. So examples of, say if you are going to drive the bike. Okay, so when you start the bike, the speed of the bike is 0 rpm, but after some time the speed go on increasing. So it does not reaches from 0 to 60 within a next moment. It requires some time, that may be 3 second, 10 second, 20 second, 30 second. So that is called as the analog inputs will vary over the period of time. Then in the fourth part we are going to discuss the function of the specified part of the given spatial IO module. Okay, so a special input output modules are also we are going to discuss in this case, that is PID modules and all this thing one. Then in the last we are going to compare the salient features of the given PLC using the block diagram. So in this chapter we also study the block diagram of the PLC, and based on that the PLCs are of different types: mini PLC, micro PLC, then modular PLC. Okay, so what is the difference between those PLC, where to select which PLC is used for which applications, how to select the particular PLC. So that thing we are going to discuss based on the features. What are the features of the various PLC that we are going to discuss, and then we are going to classify the PLC. Now what is a programmable logic controller? A programmable logic controller is an industrial grade computer that is capable of being programmed to perform the specific control function. Now if you are going to see what is a PLC, PLC stand for programmable, P stand for programmable, L stand for logic, and C stand for controller. So PLC means programmable logic controller. Now what is this PLC? PLC is nothing but the industrial grade computer. So it is a computer. Okay, so whatever the functions which are performed by the computer, those functions are also carried out by the PLC. But it is a computer with the industrial grade. Now what is the basic difference between the personal computer that we are going to use in our day-to-day life and the PLC or an industrial grade computer that can be used at the industry? So basically the difference is that in industry, the climate, whatever the surrounding, is not as per your home or office. In industry what happens, there may be a lot of vibrations are there, noise is there are so many chemicals and all these things. So whatever the computers you are going to design over there, that should be able to sustain, or that should be able to work in that environment. So it is an industrial grade. Okay, so in industrial grade means what? This PLC can be designed in such a manner that it can sustain the vibrations, it can sustain the noise level, it can sustain the moisture level. So these things are going to be considered while designing the PLC. So that's why it is called as the industrial grade computer that is capable of being programmed. So we can program it as any computer. So whether you are going to use a personal computer or you are going to use a laptop or something, it needs programming. So this PLC also need to be being programmed to perform the control function. And why you need to perform the program over here? Because I want to control certain function. Okay, say each and every process requires certain input, and at the end I am getting certain output. Simple example that you are going to discuss over here. Say in the sugar factory, they will convert the sugar cane into the sugar powder, sugar cubes. शुगर फॅक्टरीमध्ये काय होतं, शुगर केन जो असेल त्याला शुगर क्यूबमध्ये साखरेच्या याच्यामध्ये कन्वर्ट केलं जातं. सो माय इनपुट इज शुगर केन, my input over is the sugar cane, and what is the output over there? The sweet sugar is my output. But if I am going to place the sugar cane, can I directly get the sugar as a output, sugar cube as a output? ओके, मी एक ऊसाचं हे घेतलेली आहे आणि त्याला ठेवून घेतलेलं आहे, तर त्याच्यापासून शुगर क्यूब मिळतील का मला डायरेक्टली? Can I get the direct output sugar cubes? No. So we need to perform certain action. We need to perform certain process over there. Okay. So in case of any industry or in case of anything, we required input, then we have to perform certain process, and at the end we are getting certain output. Okay. So it is a three-stage process. Anything, if you want to get something, so I required input over there, I need to perform certain process over it, and then I have to get certain output over there. Now, so I have to do what I have to do over here. My program is this process. I know the inputs, I know the outputs, but I have to just find out the process which is required to convert my input into output. ओके, आता शुगर केनला शुगरमध्ये कन्वर्ट करण्याकरता काहीतरी प्रोसेस करावं लागते. ती प्रोसेस काय आहे ते मला फाइंड आउट करायचे. ओके, सो what I am going to do over here, first what I have to do, I need to just crush the sugar cane. The first step in that process of converting sugar cane into the sugar cube is what? You need to crush the sugar cane. After crushing the sugar cane, you will extract the juice from the sugar cane. आपण काय करतो, ते शुगर केन जे असतं त्याला क्रश करतो, ते क्रश झाल्यानंतर त्याच्यापासून ज्यूस मिळेल. सो वेन यू आर गोइंग टू एक्स्ट्रॅक्ट द ज्यूस फ्रॉम द शुगर केन, देन वी नीड टू फिल्टर दॅट ज्यूस. Okay, we remove the say suspended particles and all these things from the sugar cane, so we have to filter it. Then you have to boil that sugar juice. Okay, so when you are going to boil the sugar juice, then what you have to do, a slurry is going to form, that we are going to remove that unwanted particle from that this one, and then we are going to just cool it. Okay, with the centrifugal, we are going to just rotate that sugar cube into certain centrifugal oscillators, and then what happened, over the period of time, due to the moisturizations and cooling, it will form the crystals. Okay, so this is the process for converting sugar cane into the sugar cubes. Or simply, I want to prepare. Okay, so I think all of you have just drink sometimes the sugar cane juice. ओके, तुम्ही कधीतरी तुमच्या आयुष्यामध्ये ऊसाचा रस पिलेला असेल, तर त्या केसमध्ये काय होतं, सो वेन यू आर गोइंग टू जस्ट गो टू द शुगर दॅट ज्यूस सेंटर, वॉट दे आर गोइंग टू डू, दे विल जस्ट पुट द शुगर केन इन टू सर्टन मशिनरी. Okay, so that machineries has two cylindrical things, and they are rotating in the anti-clockwise, means they are rotating in the different direction. One is rotating in this direction, second is rotating in the, and in between that you are going to put the sugar cane. So what happened, the sugar cane is going to crush and the juice is going to be extracted. So that rotation of these two cylindrical things is called as the process. In that process I am going to just put the sugar cane, and then the sugar cane is going to be crushed in between these two vertical cylinders, and then at the output I am getting the sugar cane juice. So in anything, what you are going to do over here, we are converting into input into output, but for converting input into output we need to do certain process. Okay, so what is that process? That depends from output to output, that will vary from output to output. प्रत्येक आउटपुटमध्ये ती प्रोसेस व्हॅरी होत जाणार आहे, पण प्रत्येक गोष्टीमध्ये तुम्हाला इनपुट आहे आणि आउटपुट आहे. तुम्हाला आउटपुट जर हवं असेल तर इनपुट लागणार आहे, ते विदाउट इनपुट यू विल नॉट गेट एनी आउटपुट. ओके, सो an input is not directly converted into output. In between input and output there is something that is called as the process. And in PLC, what you are going to do, we are going to perform that process by programming the PLC. Okay, this process is going to be performed automatically by programming the PLC. Okay, and it will control certain functions. That function may be starting, stopping, just moving at different speed, and all these different types of functions are going to be controlled over here. A programmable controller has eliminated much of the hardwiring associated with the conventional relay control circuit. Okay, so in the previous lectures we have discussed about the relay. So my relay has certain types of 5 terminals. It has one NO contact, one common over there, one NC contact over there. Okay, and then at the terminal second side we are giving the supply. Okay, so if I want to perform certain actions, I need to just normally make a connection with a normally open and common and all these things. So it requires a complicated circuit. In the previous days, okay, in the beginning of the industrial automations we are going to use the relays, and there are hundreds and thousands of relays for automating a single process. Okay, जुन्या काळामध्ये जेव्हा इंडस्ट्रियल ऑटोमेशन नवीन नवीन सुरू झालं, at that times we are going to do all this programming with the help of hardware. Okay, and in hardware we are going to use the relays, and these relays are hundreds or thousands of relays depending on the application. So just imagine that if there are thousands of relays for a single application, what is the complicated wiring that may be? So it requires thousands of wires which are moving from here and there, and it is quite difficult for you to trace those wires and all these things. Okay, so what we are going to do? We are going to just now remove this hard wiring associated with the conventional relay control circuit with the help of program. Okay, so when the PLC we have just removed this hardwire, means we are going to just remove this relay circuitry, hardwire relay circuitry with the help of the programmable circuitry, and that's why it is called as the programmable logic controller. In the earlier days the logic is implemented with the help of relays, but nowadays we are going to implement the logic with the help of PLCs or program. Other benefit includes easy programming and installation. So there are certain other benefits also. What are those other benefits? So my programming should be easy. Okay, so I can easily program this one because here I am not using the conventional programming languages. I am going to use the special programming languages which are designed for programming the PLC. Okay, and these languages is language of symbols. Okay, here I am going to use the NO contact, NC contact, relay coils and all these things. So it is quite easy for me to program. So if I want to program the PLC, my program will be like this one. There are two vertical lines. In between two vertical lines you need to draw certain types of symbol. This is my NO contact, this is my NC contact. Okay, so NO contacts means your start push button, NC contact means your stop push button, and this is your coil. Okay, so this is the program. This is my program, and this program will be very simple. So this is start push button, this should be my stop push button, and this is my output. So as programming is quite simple over here, so it is very easy for me to write the program for PLC. And if here this is the program for your dual starter. Okay, so here we are going to use this dual starter for just controlling the various machineries and all these things. So what is the things over here? Easy programming. My programming is easy over here because I don't require the knowledge of any programming language just like C or assembly language. In the previous lecture, previous semester we have discussed about the 8051 programming by using the assembly language programming. So it is quite difficult for you to remember the instruction move a comma r0, then add C, subtracts and all these things. It is quite difficult for you to remember the different types of instructions. Okay, if you are going to use the C language, then we need to remember the syntax of C language. But in case of this PLC programming, it is quite simple. As an electrical engineer, I know the symbols. So that's why in the first unit we have discussed, symbols are very important because whatever the programming you are going to do for the PLC, that is only based on the symbols. It does not require any single written instruction. All the programming is done by using the symbols. आवाज आपले मिक्स होईल. Okay, and installation. Other benefits include easy programming and installation. High speed, high control speed is there. Okay, so speed of this one, if you are going to just control this one, so the speed of operating of the PLC is in microsecond or is in millisecond. Basically it is in microsecond, nanosecond, depending on the processing power of the processor, which processor you are going to use. Whereas my relay logic required 10 millisecond. Okay, so to operate the relay I required 10 millisecond, but when am I going to use the PLC, the speed of operation of the PLC is in microsecond or is nanosecond. So it is the very high control speed. Network compatibility, we can easily connect the number of PLCs to each other within a network. Ethernet network may be there, that may be LAN, WAN, okay. So network is very networking compatibility is there because each PLC has a separate Ethernet port. So with that Ethernet port, we can control the multiple PLC from the single one. Then troubleshooting is very simple over here. Now what is going to be happen in the troubleshooting over here? So each an input, say here you are going to observe the input I1, I2, I3, I5, I4, such as analog inputs over there. These are my digital input, these are my analog inputs. In the same manner I have output also, Q1, Q2, Q3, Q4, Q5. So troubleshooting is easy in the sense that each input has its dedicated LED. When the input is available at that time, the LED will glow. If input is not available at that time, the LED will not glow. So I can easily understood that if the LED is glowing means my input is available, and if I am not getting the output means there is certain problems with the output devices, or if I am not getting the input over there means the input sensor is not working properly. So my troubleshooting is very easy in case of this one PLC. And testing is convenience. Stating convenience is there, as well as it will provide me the high reliability. Your reliability will be very high because once you written the program into the PLC, it will remains there as long as you are not going to erase by your own. Okay, so it is completely reliable solution. And as we already discussed that it's an industrial grade computer. As it is industrial grade computer, so the effect of noise, the effect of vibration, the effect of moisture on this PLC is very less. Okay, so these are certain benefits of using the PLC over here. Now, here these are two types of PLC which are commonly used in the industry. This is my mini PLC, micro PLC over here. It is also called as the brick PLC, single unit of PLC, which consists of the power supply, which consists of your input module, which consists of your processor, which consists of your display, as well as which consists of your output module. And this is the PLC which is used in the industry, that is a modular PLC. Both PLCs are used in the industry, but this is used for small application, this is used for larger application. Now it has your power supply module, then your PLC modules, then your communication module is there, then input module, then output module, again input module, output module. A number of input module, output modules can be stuck together, so this is called as the modular. And this is the PCB plate over here, to which I can attach the number of modules as required. Okay, so it can support thousands of input output. Okay, so this one can supports me the thousands of input output at the same time, and this will use for the limited number of input output. It will supports only few hundreds, few tens or hundreds of the input output, but it can supports up to thousands of input output. So depending on your application, you can select the PLC module that you are going to discuss later. Now, the programmable logic controller. The programmable logic controller is designed. Sorry. Now, the programmable logic controller is designed for multiple input and output arrangement, extended temperature ranges. Okay, so PLCs are available in the market with multiple choices. You have ample choices available, just like your cell phone. Cell phones are available in the market with the multiple brands and multiple your models also in a single brand also. So in the same manner, my PLC is also available in the market with multiple input output. Means specifications are vary over there. Just wait. Hello. हाँ बोलिए. Good morning. हाँ हाँ. नाही 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 10वी. हां. हो. आणि एल सी नॅशनल. तर गरज नाही, काही गरज नाही. Sorry. The programmable logic controller is designed for multiple input output arrangement. Just to have discussed, if I want to purchase a cell phone, then I have a number of options available in the market with the different memory, different say input devices. Just like input devices means fingerprint sensor may be there, voice activated may be there. In the same manner, I have multiple options. In case of PLC, we have different multiple inputs. Some PLC can support 4 inputs, some PLC can support 8 inputs, 16 inputs, 32 inputs, hundreds of input and thousands of inputs also. So based on your purpose, you are going to select the PLC. If you are to deal with the tens of input, 20, 30 inputs, then you can go for the 32 input PLC. Okay, in the same manner, a PLC can also be available with the output arrangement. So some PLC have 4 outputs, some PLC have 8 outputs, some PLC have 32 outputs, 16 outputs. So based on your requirement, you can select the PLC for the required input and output configuration. As the number of input and output go on increasing, the cost of PLC also increases. Okay, this is the major thing that you have to. And when you are going to select the PLC, always select the PLC of somewhat higher rating, so that during in the future, so definitely the expansion is going on, your requirement go on increasing, so at that time you are not supposed to replace the PLC. Okay, so when you are going to purchase the PLC for the first time, you have to purchase the PLC with some additional inputs which may be required into the future. Then extended temperature ranges, based where you are going to use the PLC, based on that the PLCs are available with the different temperature ranges. Some PLC can support up to minus 20-40 degrees centigrade. Some PLC can use for the normal temperature of 30 to 30 degrees centigrade. Some PLC can be designed to work at a temperature of 80 to 100 degrees centigrade also, and some PLC can be designed to work at higher temperature also. So based on your requirement, you need to select the PLC. Okay, so if you are going to use in India at normal applications, so temperature range is 50 degrees centigrade is sufficient over there. Immunity to the electrical noise. Now in the industry, there is a lot of electrical noise which is coming from the various devices. Now what is the electrical noise? Electrical noise is nothing but the unwanted signals which are produced because of sudden switching on and off of the machines. My waveform is the AC sinusoidal waveform. It is a pure sinusoidal waveform. But what is going to be happen when I am going to use the power electronic devices or the electronic circuitry at that time? So when I am going to switch on certain devices, so imagine that this is my pure waveform over here. Just try to understand, it is a okay AC waveform. But when I am going to use in the industry, when I am going to switch on certain devices or switch on, now my waveform will be like this something, and this is called as the electrical noise. Now this electrical noise means unwanted increase or decrease in the signal strength. If this my I am not designed, my PLC is not designed to just cope up with this electrical noise, then my circuit is going to be damaged, because PLC are basically electronic circuitry. Okay, inside the PLC there is a microcontroller, and microcontroller is very sensitive device. So if it is going to provide certain high temperature or something, so basically what happens, this microcontroller circuitry may get damaged. So you need to just design the PLC in such a manner that it should be compatible, it should be just you mean to the electrical noise. If certain electrical noise is there, to certain extent it can just handle it, it is not going to be directly damaged. And the resistance to the vibration and impact, basically as we already discussed, in the industry there are tremendous vibrations are going to be takes place. Okay, because number of machines are there, pressing machines are there, then grinding machines are there, number of machines are there, and those machines causes the number of vibrations, a lot of vibrations in the industry. So my PLC should be able to withstand those vibrations, the circuit does not going to be damaged with those vibrations, as well as the impacts. Okay, so when you are going to discuss the case of your pressing machine, in the pressing machine the RAM is going to be just go into the die, and that causes the impact over there, so that produces the vibrations. So in that cases, if my PLC is not proper over there, then that causes the damage. So program for control and operation of manufacturing process and equipments and machinery are typically stored in the battery bank and non-volatile memory. So whatever the program you are going to write into the PLC, okay, so that program is what for? The for controlling the operations, control and operation of manufacturing process. We need to control the manufacturing process, where we want to just execute the manufacturing process with the help of certain sensors, automate. So that program should be stored into the battery bank. Backup means there should be inside the PLC there should be a battery, because in case of the power failure in the industry, okay, my program does not get erased. So we are going to use the lithium ion cell over there, a coin size. We have 1 rupee, 2 rupee coin size lithium ion cell is there, and that lithium ion cell can just provide the battery backup when in absence of your supply power. Or you are going to use press in the ROM, read only memory, non volatile memory. There we already discussed in the previous semester, there are two types of memory: RAM memory, that is random access memory, which is a volatile memory, and the second one is the ROM memory, that is read only memory, that is a non volatile memory. So basically when you are going to press the program into the non volatile memory, then in case of power failure also, my program does not get erased. A PLC is an example of real-time system. This is very important thing. What is meant by real-time system? Real-time system means what? As the changes are going to be occur in the system, the same time the changes are going to be reflected. या मोमेंटला जे काही होत आहे ना तेच हे होणार आहे. So these are the real-time system. PLCs are the real-time system. Since the output of the system controlled by the PLC depend on the input condition. So as soon as the input condition will change, at the same time my output also change. Okay, so that's why it is called as the real-time system. Whenever there is a change in the input of the system, this that will certainly change the output of the system at the same moment. Initially, the PLCs was used to replace relay logic. Basically, what happened in the early days, as we already discussed, there are complicated circuitry for controlling the industrial automation or for implementing the industrial automation, and which require thousands of the relays. So it is quite difficult for you to implement the relay logic. Okay, and if certain changes are occur into the logic, we need to completely rewire this panel. Okay, and rewiring takes 1 month, 2 months, see up to 6 months also in case of the complicated cases. So what you are going to do, we need to find out the solution for this one, and sometimes the cost of changing or cost of rewiring is more than the cost of implementing the new circuitry. So we want certain simple solution which can be easy, which can be the logic can be replaced or logic can be modified with a very simple way, in a very simple way, and within a very small period of time. So for that purpose the PLCs are inverted in between 1960, okay, to 1965, but it is capable not only for performing relay switching tasks but also performing other application as. Okay, so initially these PLCs are only used for replacing the relay logic. Okay, but when these PLCs are invented, they have not only replaced the relay logic, they have provided certain other advantages also. What are those? So they are capable not only of switching the relay task but also perform other activities such as timing. The PLCs can provide the internal timer, time delay. Okay, they can be used for counting is the say jobs which are going to be completed within the period of time. Then they are used for calculating, then comparing, okay, and other processing of the analog signals. Okay, so what is going to be happen over there? These PLCs can not only replace the relay logic, but at the same time they will provide you the other applications such as timer. Okay, so in the earlier days we need to use the separate timer, but with the help of PLC, with the invent of PLC, the need for the using of the separate timer will going to be eliminated. Separate counters are also not going to be used because this timer, counter, calculating, and comparing and all these things are internal inside the PLC. So just you need to write the program for that one. If you are going to use the timer block, then it will provide you the time delay. If you are going to use the counter block, then it will provide you the counting. Okay, so on delay timer, off delay timer is there, up counter is there, down counter is there. For calculations we are going to use the various mathematical tools such as addition, subtraction, multiplication, division, all these things. For comparing we are going to use the operators such as greater than, less than, equal to, not equal to. And for processing the analog signal also, it is quite difficult for you to process the analog signal with the help of the relay logic, but with the help of PLC my processing of analog signal is quite simple, very simple is going to be open over there. Okay, so these are the some things which are going to be just done with the help of PLC. Now, how the PLC looks like? So this is the basic block diagram of the PLC. If you are going to see any PLC in the world, it has basically five say blocks, or it is divided into five blocks. So first one is the input module, second is my output module, third one is called as the processor module, and fourth one is called as the power supply module, and the last, which is not a part of PLC, is the programming device. Okay, without programming device we cannot program the PLC. The programming device may be dedicated programmer, or it may be your laptop or computer, or it may be handheld programmer. Okay, so these are the various blocks of your PLC. Okay, so in the tomorrow's lecture we will discuss in detail about the block diagram on various blocks of the PLC. Today is it clear that what is PLC, what is the application of PLC and all these things? Okay, so in tomorrow's lecture we will discuss about the parts of PLC and all these things.